Welcome to this demonstration of SceneGEMS, a scenario generation and execution framework for the safety assurance of maritime autonomous surface vehicles. Autonomous surface vehicles, referred to as ASVs, must complete their missions in the presence of other maritime traffic. To do so, they have to comply with the international regulations for preventing collisions at sea, also known as the COLREGS. To give strong guarantees that an ASV is safe and COLREGS compliant, we need systematic assurance in every possible semantically different open sea scenario. A scenario can involve situations such as overtaking, head-on, and crossing. Since field tests do not scale to multi-vessel encounters, these systems are primarily tested in realistic simulations. A great body of work has been done to construct comprehensive assurance suites that provide sufficient guarantees after simulation execution, during which the ASV under test is evaluated for COLREGS compliance. Our tool is an end-to-end framework that integrates systematic model-driven assurance suite generation, realistic simulation execution, and runtime compliance monitoring, providing a scalable and reproducible assurance workflow for ASV systems. For generating assurance scenarios, SceneGEMS uses high-level functional scenario specifications. The user specifies the model in our editor using refinery syntax and then simply clicks Generate Initial Scene. An assurance suite that provides strong guarantees requires a complete set of semantically different test scenarios. Our tool is capable of generating such assurance suites by deriving scenes in larger batches. We provide various presets of functional scenario specifications from which the user can select the desired set, for example, the 3-vessel zero-obstacle cases, and start generating initial scenes. Each model in the set represents a semantically different concrete scenario. Once the generation is completed, the user can select a scenario from the assurance suite and initialize it for preview. Our selected scenario is a double crossing scenario, in which the owned ship, marked in blue, has to cross two target ships to avoid collision, while the target ships maintain their course as required by the COLREGS. The tool provides a comprehensive preview animation that shows the potential outcome of the encounter if the owned ship takes no action. As we generate challenging scenarios, the outcome will always be a near miss or a collision. On the right-hand side, concrete vessel properties and estimated states are displayed at each time step. Test case execution is orchestrated through the WARA-PS core system, an integration platform developed by the WASP Research Arena for Public Safety. Our interface connects to the WARA-PS MQTT broker, or a local broker that implements agent communications and allows users to place scenarios in the GPS coordinate system. Before initializing a simulation in SceneGEMS, the user can configure various parameters. First, connection parameters can be set for each simulated vessel. A vessel can be controlled by an external ASV system, or it can follow a predefined trajectory autonomously. It publishes state and listens for commands on an MQTT topic within the WARA-PS infrastructure. The vessel can be controlled externally through a UDP connection using a defined port. Physics models can be configured or generated automatically for each vessel. Moreover, the user can specify real-world vessels, enabling hybrid simulations. Finally, the underlying simulator engine can be selected, along with the simulation speed and environmental effects that influence how the physics models behave. Once the configuration is done, the user can initialize and start the simulation. The preview and simulation animations are displayed on a shared canvas. On the right-hand side, the panel shows the runtime monitor results at each time step. The monitor identifies emerging COLREGS situations and reports rule violations. In this scenario, the owned ship failed to take early and substantial action as required by the COLREGS, ultimately resulting in a collision in both corresponding COLREGS situations. This violation occurred because no COLREGS-compliant control software was connected to the owned ship. The user can connect external control software through the previously configured port to guide the owned ship. In the absence of an automated control software, to demonstrate the external control, we use the popular Mission Planner tool to connect to the owned ship and manually define a safe trajectory at runtime. By following this trajectory, the owned ship remains COLREGS compliant throughout the scenario. SceneGEMS allows users to export and load simulation results for later analysis or to be used as assurance evidence of COLREGS compliance. To learn more about the project, visit the official repository or get in touch with the authors.